If you were expecting a different talk, you might be in the wrong room. Wow, I usually get a better laugh out of that. Okay, so a few things about me. I'm a developer evangelist at an identity and access management company called Auth0. I run the Seattle Identity and Security Meetup as well as the Auth0 online meetup. And I'm an avid Twitch streamer and member of the Live Coders dev team. So if you go to livecoders.dev, that's going to forward you to our team page on Twitch, and you can find, I think there's like 65 of us now, right? And we all do live coding throughout the week. I try to hit it 3 times a week. Monday morning at 8 a.m., like noon on Wednesday, and about 3 on Fridays. That's all Pacific time. I've been a software developer for around 20 years, focused mainly on web development. I've done a little bit of mobile development, and I got into evangelism because I enjoy teaching and I enjoy going to conferences as well as speaking at conferences, and I hate being in management. So after you hit about the 10-year mark as a developer, everybody wants to shove you into management, and so this was my off-ramp, right? I still get to go teach, I get to go to conferences, I get to meet fun people, so that's kind of my background. This is me and my dog Louie, and we're hanging out in the beautiful Pacific Northwest. And for all of you Midwesterners, these are what mountains are, right? So yeah, that is the Chinook Pass through the Cascades in central Washington, well, kind of west central Washington. So I asked on Twitter earlier this year, what are the most common reasons to roll your own authentication? And I got several really good reasons, and of course all of them are wrong. And I say that because authorization and authentication are deceivingly simple. If you look at this slide, this diagram, you have a user who wants to get access to a resource, and if you look at this diagram, it looks easy. But the problem space we're talking about is extremely critical. If something goes wrong, it goes catastrophically wrong. Think 11.4 million euros level of catastrophe in the event of a breach, right? That fact alone makes this topic something that requires a lot of attention. So let's start by talking about authentication and web applications. And by this I mean traditional server-side rendered applications and single-page applications as well, right? And we'll start off with cookies. And cookies are traditionally used with server-side web applications built on frameworks like PHP, .NET, Java, even Node.js, you can use cookies. And those apps look kind of something like this. You have a browser, and then you have a server that has your application, and maybe it's connected to a database in some form or fashion. And when the user submits their credentials to log in, if it's successful, the server is going to set a cookie in the browser that represents that user's session, right? The user is authenticated. The web app knows this, and the browser knows it because it has a cookie from that web application, right? On subsequent requests to the server, the browser attaches the cookie to the request that's sent to the server. The server sends back the requested HTML and any sensitive data to the browser that the user wants to access, right? We're all pretty familiar with this form of authentication. If the cookie expires, or there's no cookie in the request made for the protected data on our web application, the server is going to return a 302 redirect status, right? And this will tell the browser to do a full page redirect to somewhere the user can re-authenticate. And if the cookie, 302 redirect. Once they have that and have re-authenticated, the application can once again send them secure data, right? In a single page application though, we typically use token-based authentication. This works a bit differently. We still have our browser, and when it navigates to our application, the app is compiled and it's downloaded and runs in the browser itself. We usually get data from an API, not necessarily our API, it could be someone else's API as well. And we get tokens from something called an authorization server, which is a fancy term for a set of endpoints whose purpose it is to issue tokens. That's like all an authorization server does. The user submits their credentials and login to the authorization server itself. And if everything checks out, that authorization server is going to issue a token back to the browser, right? The token is sent to our API with any request for data, and the API will verify that token, usually with some form of middleware. Your application code doesn't really need to care about the token. You have some kind of middleware that's sitting in between your app and the incoming request that'll make that determination for you, right? And if everything checks out on that end, the data is returned as JSON, which the application can then consume, right? Okay, so here's a question. And I know at least one of you are thinking this question in your head right now. Why would we not just secure our single page applications with cookies, just like we do with traditional applications? That's actually a really good question, so I don't think you're a sarcastic SpongeBob. There are some reasons why. One reason is that cookies only work on the domain of the application. So if I get a cookie from example.com, I'm not going to be able to use that cookie on twitter.com. That cookie's not going to automatically traverse back and forth, right? So if everything is on the same domain, then cookies are okay. As long as I'm operating on spongebob.io, I guess we could use cookies, right? But a lot of single-page applications call APIs that live in other domains they may not need, or they may need to in the future, right? Especially as the application grows, you start to access a whole bunch of data from other places. And if your API is on a different domain from your application, that cookie is not going to work. If you don't have that problem and your single page and your backend are both on the same domain, you probably should consider securing your application with cookies. It's a far simpler, far older, well-understood method of authentication. But there are some things you need to consider when doing it. You need to put your authentication layer in your backend, not in your single-page application. But do authentication with routes served from the backend that use cookies for securing the data that is moving between the single-page application and the backend. One thing you do have to keep in mind, though, if you do this, when an application uses cookie-based sessions in a traditional web application, when the user tries to access a page, if they are not authenticated, remember they get a 302 redirect status, and this is going to redirect the entire browser somewhere that the user can re-authenticate so that the cookie can be regenerated. Single-page applications request data using AJAX calls, so if your cookie's expired, and the response is going to be a 302 redirect. In the single page application, we need to add logic to handle that 302 redirect, right? Because your standard library is not really going to know what to do with that. We might be expecting a JSON response. We don't necessarily know what to do with an HTML page with a 302 status. If you can handle the status and there's really no problems with doing it, just be aware that you'll need to do that. However, on the other hand, if you know that you're going to need to scale, meaning operating your application front end, back end on more than a single server involving load balancers or that sort of thing, or you already have APIs that are already on another domain, then you're going to want to use token-based authentication, right? It's just going to be the easiest to do. So about tokens. A token is a very powerful artifact because the bearer of a token can access your secured data, right? Historically, it's been recommended that we store tokens in local storage in our browser. You can go out and look at articles on OpenID Connect or OAuth all over the internet, and they talk about just stashing them inside your local storage, and that's great. But we actually should not do this because local storage has a distinct lack of data protection. First of all, any JavaScript running on the page has access to local storage. So if you happen to be serving up ads or some other third-party JavaScript is pulled into your page, those scripts have access to your local storage. So a cross-site scripting attack, so you can have a cross-site scripting attack if you have a malicious script or a compromised third-party script. It can read the local storage object and steal all of its contents, and any user info, any sensitive data, and any tokens that you put in there are basically up for grabs if you are a victim of a cross-site scripting attack. On the other side of that coin, cross-site scripts can access local storage to push malicious information into your local storage, which can potentially make it a somewhat untrustworthy source. If you're storing a token in local storage and you're relying on an administrative scope being defined in there, a script could potentially inject that into your token, right? And now they're an administrator in your application, at least for the UI portion of it. Hopefully you've got more secure access controls in your backend. Finally, all local storage is shared within a domain. So if you have multiple applications running on the same domain, all of those applications can access that same local storage object. So they could reach into others' tokens and things like that if you have different authenticated apps in the same domain. The most common reasons we put data in local storage is session persistence. So that user still has a token if they leave the application and come back. We don't want to make them re-authenticate every time they come to the application, especially if they just hit the refresh button in their browser, right? That would be incredibly annoying. I refresh the page and it wants me to authenticate again, right? So what can we do instead of putting our tokens in local storage? We want to store our sensitive data in application memory. And when a user authenticates, our authorization server sets a cookie for the endpoint of the authorization server itself, the authorization server that's issuing the tokens, right? In that browser that represents that user's session to the authentication server or authorization server. This cookie is not sent in the API or anything. It's just the knowledge of what the user's session state is when the authorization server itself, right? So if we need to go and do something like refresh the browser and we lose all of our state in our application reload, we won't have our token anymore. But what we can do is use that cookie to check the session state and see if the user's authorization server session is still valid. If it is, we could actually request a new token silently without prompting the user for credentials. This does assume that you're not trying to elevate scope or request a different audience. So if it's the exact same authentication you're attempting, the cookie will suffice, right? Because the authorization server still knows about that user and has knowledge that they are logged in. So having said that, here are some more guidance with using tokens for single-page applications. This is a little bit of a history lesson. In 2012, when the OAuth 2 specification was adopted, single-page applications were not mainstream, right? AngularJS, the granddaddy of SPA frameworks, was born in that time frame, but it didn't really become popular until around 2014, so about 2 years after the spec was locked down. Vue.js was born at about 2014. It took at least a year before it became mainstream and people started using it heavily. So both of these SPA frameworks became relevant long after OAuth 2 was adopted. And historically, the guidance for doing authorization with browser-based applications was to deliver a token in the hash fragment of the URL. So you go to your authorization server, you authenticate, and it calls your callback URL in your application, passing a code in the hash fragment of your URL. Hopefully you guys have all seen that in the past. If not, you should be at Joel's talk. There's some inherent security risks with doing this, right? The token is vulnerable in a number of places. You have it in the redirect URL because you are redirecting the token to some URL that you're assuming is owned by the application. But if that redirect URI was hijacked, you could be sending your token to somewhere else, right? In addition, it's accessible in the browser history, which is also accessible by all the same JavaScript exploits that I was talking about earlier. It's also potentially accessible in the referrer header. So if you are under attack and a malicious page is requested right after authentication takes place, then the attacker can just look in the referrer header and take the token right out of there. Finally, the app doesn't know where the token is coming from. It just sees that it's in the URL hash and it uses it. So it doesn't necessarily have a way to verify that it's coming from a trusted source. If it was injected maliciously from somewhere, we would have no way of knowing, right? So authorization servers and app developers who work in the space creating libraries for OAuth and OpenID Connect have been working to actively mitigate these risks, right? So the mitigation guidance has been around for at least 7 years. You can go out there and find articles to talk about each one of these specific scenarios and how to not expose yourself to them, right? There are no new threats in this approach. These same mitigations are going to continue to work. There are no new vulnerabilities that have been found, their way around these mitigation strategies. But as modern JavaScript and applications evolve, we reevaluate the recommended practices on a regular basis, right? So these are roughly 5, 6 years old, these mitigation techniques that I'm talking about. And it's time to have our recommendations be a little bit more secure, right? So what I'm going to be talking about is recommendations directly from the IETF, and it was drafted this year, so this is new stuff for web applications. But the approach we are recommending is kind of old. It's actually what we do currently in mobile applications. We're just applying it now to web-based applications. So it's not exactly a new approach, it's just new to the world of the web browser, right, and browser-based applications. In this scenario, we basically exchange a code for a token. And that works something like this. I'm going to go over this quickly, but don't worry too much about it. I have something to help you later on. The first thing we need to do in our applications is create a random string called a code verifier. This is a high entropy random string. And next we'll use that to compute another random string from that verifier using a hashing method that gives us something called a code challenge, right? Now when the user logs in, the credentials and the code challenge are sent to the authorization server. The server then returns a code which is received by the browser in the hash fragment. And this is fine because intercepting this code isn't dangerous. The code by itself can't be used for anything, right? It can't grant somebody access to your resources if they manage to steal the code. All right, once we have the code, we take that code and the code verifier and we send them both to the authorization server, right? Now what we can do is we can recalculate the code challenge from the verifier, and then we want to make sure that the two match, the one I sent with the original request and the one I sent with the callback, right? And if they match, then a token is issued as a JSON object and sent to the application and it can consume it, right? Okay, now all the mitigations for the risks that I talked about earlier with having the token in the URL, we don't need to worry about those anymore if we use this new code-based approach. And if you're familiar with OAuth grants, like there are several different grant types, the one that I'm talking about right now is called Authorization Code Grant with Proof Key for Code Exchange, lovingly referred to as PIXE. All right. So this seems like kind of a lot, right? It's several steps to take. There are hashing methods involved, exchanging codes, blah, 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 blah. But you don't have to worry about this too much because SDKs can handle this for you, right? Professionals who work in this space that define these sorts of things build SDKs to make it simple for you to use, right? Ultimately, if you're building a new application, you need to add authentication to it, then you should probably consider using the PIXE approach. It's more secure and there are fewer mitigations that you need to concern yourself with. But if you have existing applications that use the token in the URL approach, as long as you are considering the mitigations that I talked about earlier, there's no new threat that you need to worry about. You don't need to run out with your hair on fire and start refactoring all of your applications. your applications are probably just as secure today as when you wrote them, right? That brings us to basically the second half of my talk, and that is how to actually implement Pixie in a Vue.js application. And how do we take a generic authentication specification and weave it into a Vue application, right? So let's start with a bit of a to-do list about what I'm going to be covering. We'll add a global authentication service via dependency injection using a plugin, a Vue plugin. If you're not familiar with that, I'll give you an example of one and how they work. We'll restrict client-side routing based on authentication status. We then handle authentication events like log out and log in. Look at conditional template formatting based on authentication status. Consume the authenticated user's OpenID Connect profile, so actually displaying like their avatar, name, email address, whatever we want to actually display in the page itself. And then sending an access token with any API requests we might make from our single page application, right? So we're going to cover all of these scenarios. Authentication is a cross-cutting concern. Different portions of our apps will need to interact with it in different ways. And Vue.js offers two ways to handle cross-cutting concerns. Mix-ins are a flexible way of sharing functionality across Vue components. You simply create an object that defines some shared methods and then declare the mix-in as a part of your component definition. But this isn't really what we need for like a global cross-cutting concern. This is handy if you have certain events that a group of components need to be able to handle, and you want to have that defined in one place. You create the mix-in, you add it to the components that need it, and then those components have that functionality. Mix-ins aren't really appropriate for like a global level service, right? Plugins, on the other hand, are for global level functionality in Vue. You're probably already familiar with using plugins if you've ever built the simplest Vue app possible, if it used routing or it used Vuex for state management. Those are both Vue plugins, and they're implemented in exactly the same way I'm about to show you. Here's a common example of adding Axios as a global HTTP request handler, making it available to any component that needs it, right? So I have a file, plugins, Axios.js. I import the library. I export an installer function that takes in the Vue object itself, and then I attach Axios to a $HTTP prototype property of Vue. And now any Vue component can simply use it I have to register the plugin first, so that's the next step. So in your main JS, you import that plugin, and you just simply tell Vue to use it, right? And then in your component, any component whatsoever, that HTTP is going to be hanging off of this, right? So any of your components can now access that thing. And this is basically how dependency injection in Vue works. It's very convenient. This makes our making and plugging in our auth service pretty clean. In this example, our main.js imports the plugin and tells Vue to use it, passing along configuration values that are needed. Things like the domain of my authorization server, my client ID. If I want to request an audience to get an access token, I can pass that stuff inside my main.js. And since we're delegating authentication to an OIDC-based identity provider, we pass along the domain, the client ID that we got when we registered our application. Since the provider is also handling our OAuth-based authorization as well, we pass in a specific audience, right? So because I passed in the audience, I'm going to get an ID token because I'm authenticating. Because I passed in the audience, I'll get an access token. So I'll get 2 tokens, basically, just by adding that line. Finally, there's a bit of magic telling the service how to handle callback redirections. And that's what this little function is here. And I think that's easier to understand actually seeing it in a demo. So we'll get to that in a bit. Now you may be thinking, hey, wait a minute, where's this authentication service coming from, right? There's a whole bunch of math and fanciness involved that I'm hiding under that create service call. If you recall earlier, I said you didn't need to be too concerned with generating or parsing cryptographic keys or anything like that. And this is because SDKs can handle that for us. And at a low level in my application, I'm taking advantage of an SDK that we released about 4 weeks ago called the Auth0 SPA SDK, which we created specifically for single-page applications that wish to use authorization code grant flow with Pixie that I described earlier. So the service is simply a thin wrapper around that SDK that makes it behave in a Vue-like fashion. And this SDK is not intended only for Vue, it's intended for all SPA frameworks. So if you're writing a SPA on vanilla JS, you can still use this. If you're writing it in React, you can use this. Angular, Svelte, I don't know, there's like a million of them out there right now. So it's appropriate for all of those platforms. And if you go to our website to auth0.com/doc/quickstarts and then go into single page applications, you'll see documentation for how to use them for each of those platforms if you want to do that. This brings us to another nifty feature of Vue. It's Reactivity Model. And we're all probably familiar with Vue's Reactivity Model in a component defined like this, right? We start out defining a data element named foo with a template bound to the value bar. And when the mounted method executes, it changes the foo value to baz, and Vue's Reactivity Model automatically updates the template's value to match what the new data value is, right? We don't have to handle that in any way. It just automatically does it for us. That reactivity model is not limited to UI components. We can leverage it anywhere we like. The authentication service implementation is simply another reactive Vue component that we wrap inside, that we use to wrap the SDK, exposing a set of reactive properties and methods that we can consume from any component, right? So this is the exact same setup that we saw on the previous slide, right? We have a data element. We have, let's see, yeah, we have an authenticated and a user reactive properties within our component, and then we have some methods that we can use that simply delegate into the Auth0 client, right? So this particular example handles the complex redirect callback logic described earlier, then fetches the user profile and notifies anyone that cares that the user is authenticated through the reactive properties. This will become very handy later and make certain scenarios very simple. There's more to this service than we can see right now, and you can check that out in the source of the demo once I give you a URL to it. And with that, we've injected a reactive authentication service packaged up nicely as a Vue plugin, right? So now that we have a reactive auth service, we can leverage it now to handle restricting access to client-side routes defined in Vue Router. And Vue Router is pretty easy to use. It's in common practice right now. I'm not aware of any other router that's being used by Vue developers. And out of the box, it offers several ways to make decisions about route navigation. In this example, we have two of the most common forms of route guards. A global defined in the router itself that affects all routes of a given router. And then a per route guard that is applied directly in the route definition itself. The function signature is the same for both. We're given the route that we're trying to navigate to, the route that we're trying to navigate away from, and then basically a callback method that allows, if I just call next, it's going to allow the navigation to happen. But I can also pass a path into it to redirect that route navigation somewhere else, right? So with that in mind, it's pretty trivial to implement a guard that takes our authentication service into account. This guard will allow navigation if the user is authenticated or redirect them to the authorization server, this method right here, passing in some metadata about the current location of where they're trying to route to. That's part of the magic that I was talking about in the route service itself, or the registration piece. One thing to note here is that we pass some app state along with the request that lets our application know where to send the user back. once they've successfully authenticated, right? So back in our router, we can simply apply that route guard to any route we wish to require authentication. In this example, I'm applying it directly to a specific route. We could apply it globally, but we'd need to make sure that we include any public routes from exclude any public routes from consideration. So like if you have an index page that everybody should be able to get to, if you're going to do a global guard, you need to put some bit of logic in there that says, hey, go ahead and allow index to go through. Otherwise, people are going to hit your website and immediately go to your authorization server, and that might be jarring to them, right? And with that, we've restricted client-side routes based on authentication, right? With all that done, how do we actually let the user log in to our application? It's actually surprisingly simple. With our login service exposed as a global service, we literally just define methods to call the relevant methods in our service. Here, our login method delegates the login to login with a redirect method that redirects a browser to the identity provider for authentication. There's an alternative version of this that will do it through a pop-up, right? So it leaves them on your website as opposed to going to the authorization server. The logout method simply calls the identity provider to end the session and then routes the user somewhere else in the application, another public route somewhere. With those methods exposed, we simply call them via the click directive in our UI elements. Can you guys see that okay? Yeah, okay. Cool. So very clean, very straight through. And with that, we've implemented handling login and logout in our single page application. There are times when we would like to show or hide elements within our application based on the authentication state of the user. And I hope you guys see where this is going right now. Because my authentication service is reactive, I can simply bind directly to them, right? Conditional format is pretty trivial. We can use an if directive to ask the service directly. If the user's not authenticated, we show this login button. If the user is authenticated, we show them the logout button. When the reactive values change, the UI updates automatically for us. Note we're also checking with the service to determine if it's in a loading state. When you first instantiate the service itself, it's reaching out to the identity server or authorization server to get some information that's necessary to validate the keys that it gets back. And there's some lag time in that. So we don't want to expose UI elements that could trigger a method call into our SDK that's not ready yet. So that's why the extra check is there. There's probably a cleaner way of doing that within the Vue app, but this is the way I did it. So yeah, I already explained that. So with that, bam, that was the fastest one we've done so far. Let's move on. When the user's logged in, we want to give them some indication that they are logged in. The most common way of doing that is showing them their little profile image from the authorization server and maybe using their name up in a login widget sort of thing, right? And this is pretty simple too, based on the reactivity model. Here we use a computed property to return the user's profile if it's available, or some default values, basically your anonymous chaos monkey sort of thing. And when the user becomes available, we just swap it in. And now that's rendered in our application. So we're reaching the end of my presentation here. We only got one task left to do. If you recall, when we configured the user service, we supplied an audience value. And we could have also specified OAuth scopes that we wanted as well in the same place. The net effect of doing that is that we're issued an access token along with our OIDC-based ID token at the same time. We do it in one trip instead of having to make multiple trips to do that, right? So here's the component. Here, the component loads its own data when mounted. We simply ask the auth service for a token and make the request using an HTTP request service, setting headers appropriately, right? This might look a bit different if you're using Vuex or any other Flux-like library, but you kind of get the idea. The one thing to point out here is notice the service method is called to get a token silently. And this is a nice feature of the underlying SDK we're using. it checks to see if the token is currently expired or invalid in any sort of way, and it silently requests a new one from the authorization server. And as long as we're not elevating any scopes or audiences, the user doesn't need to have any interaction with that process. It'll just give us a token back, right? Very nice, very clean. If you've ever, like maybe 2 years ago, built this type of functionality, you remember having to juggle tokens and actually read into them to see what their expired times are and maybe do something to request that token. The Auth0 SPA SDK handles that for you, to where you don't even have to think about it. And with that, we've completed our World 1 tour of securing Vue and with OpenID and OAuth. How much time do I have left? 25 minutes. Okay, cool. So let's do some demos. All right. One thing I forgot to mention, I should have done this at the very beginning of the talk, is this URL will take you to a post on the Auth0 community page about this presentation with a link to my slide deck, a link to the demo application up on GitHub, all of the advice I gave in my talk that were security related, the sources of that advice, as well as like my Twitter account and my live stream page. So that's all you need to get all the information for this talk. All right, so take a picture of it, write it down, send it to your mom, whatever's necessary. All right, let's see if I can actually get this up and running. Well, that's not what I wanted in that show. Okay. All right, so I just have a little bash script that basically starts my front-end application and my back-end application at the same time and running. So that's what it's doing. It's running on 8080, and my API is running on a different port. But just to kind of show you that the API is up and working, we'll take a look at that real quick. What's that? Am I showing the wrong screen? I am. How do I make that come up here? It's supposed to be mirroring. Let's see.
It's the dragon issue.
Yeah. Give me token now. Burn it all down. Let's see. Can I drag this over there? Oh, I know what to do. What desktop is it showing? Displays, arrangement, mirror. Is that better? Yeah, that's actually the code I'm trying to show you guys. So my API is running on port 3333, and I have two routes on it. I have a public route, and I have a private route, right? And if I come in here and I send a request to the public route, you can see I get data back. But if I try to send that request to a private route, I get my 401 unauthorized. I can't hit that route. Let me bring up a browser really quick. Log in with my GitHub. There we go. Sorry, I should be talking while I'm doing this. What I'm doing is I'm trying to get an access token to where I can show you if I have a valid access token, it will let me through. And I'm just going to Auth0 to the little test page that